Hey guys, Mr. Gucci here, and I thought I'd help you out by making a video on periodic trends, specifically how to put elements in order by periodic trend. So what I've got here is I've got some sample problems here. Some elements we'll put in order by increasing ionization energy. Some elements we'll put in order by decreasing effective nuclear charge, and some elements we'll put in order by increasing atomic radius. And to help us out here, I have got a periodic table. So as we recall from class, all right, let me get my little pen going. Good, it's going. So, as we recall from class, the major trend on the periodic table is this, all right? And it is that on the upper right corner of the periodic table, right here, you have elements that pull on electrons strongly. Okay, that concept we call effective nuclear charge. Effective nuclear charge is how hard the nucleus is pulling on its electrons, specifically the outermost electrons. And then down here on the bottom left, these elements have a weaker pull on their electrons. All right, weaker pull on electrons. So up here in the upper right, you have a strong pull on electrons. And down here on the lower left, these atoms have a weak pull on their electrons. And all periodic trends work off of this general principle. So I'm going to put that down here. All right, I'm going to just put down here weak pull on electrons, and up here strong pull on electrons. Okay, so now let's take a look at this. We want to put these elements right here in order of increasing ionization energy. So let's first figure out what that trend even looks like. All right, let's go to the periodic table. So ionization energy is the energy it takes to tear away an electron. All right, so ionization energy is the energy it takes to tear away an electron. Now, if you think about it, up in the upper right, where there's a strong pull on the electrons, it's going to be very hard to tear away the electrons. So the ionization energy is going to be higher up here. And where you have a weak pull on electrons, the energy it takes to tear away electrons is going to be lower. So it's going to be lower down here, which means an increasing trend going from low to high is going to look like this. All right, an increasing trend is going to go like this. So we're going from the bottom left to the upper right. All right, you might be thinking, Mr. Gucci, how do I draw this on? Am I just going to draw this on my periodic table? No, I recommend you don't. What I recommend you do is for every one of these little problems here, just draw yourself a little mini periodic table that you'll use to sketch things out. Okay, so increasing ionization energy goes from bottom left to top right. So what you're doing is you are just putting the elements in order from bottom left of the periodic table to top right of the periodic table. Okay, so let's put these guys in order. Let's find them on the periodic table first. All right, so we have got zirconium, which is here. All right, we've got phosphorus, which is here. Then we have got cobalt, which is here. All right, so the order from increasing ionization energy goes, starting here at the bottom. All right, here we go, starting at the bottom is zirconium, cobalt, phosphorus. So the answer here is, in order of increasing ionization energy, zirconium is the lowest, followed by cobalt, followed by phosphorus. So that's the order. Okay, let's try another one. All right, here we go. Same trend, increasing ionization energy. If we're going from bottom left to top right, cobalt or carbon, indium, and aluminum. So let's find those guys. All right, let's find those guys. So we have got carbon, we have got indium, and we've got aluminum. So again, the trend is going from bottom left to top right this way. So First, we're going to have indium. The lowest is going to be indium. The next one is going to be aluminum. And the last one is going to be carbon. So increasing ionization energy goes indium, aluminum, carbon. Indium is the easiest to pull electrons off of, followed by aluminum, and lastly, carbon. Okay, so there we go. That is periodic trends. Let's try another one. Let's change my color. That was green. We'll go blue. All right, so this next trend is decreasing effective nuclear charge. So effective nuclear charge is how strong the atom pulls on its outermost electrons. Decreasing. So we're going from big to small. All right, from big to small. So, well, that strongest pull on outermost electrons is up here in the upper right. It's weakest down here in the lower left. So if we're decreasing by effective nuclear charge, we are going from the top right to the bottom left. So that's the trend we are going to be following, going down from top right to bottom left. Again, you don't need to draw this on your periodic table. Just sketch yourself out a little miniature periodic table yourself and be like, okay, this one is going from top right to bottom left. So you are going to align these elements from the top right to the bottom left. Let's try these first ones. Strontium, chlorine, and tin. Let's find them. So chlorine is there. Strontium is there. And tin is there. So going from the top right to the bottom left, the order of decreasing effective nuclear charge is chlorine, followed by tin, followed by strontium. So chlorine, tin, strontium. Decreasing effective nuclear charge. Chlorine is the strongest, tin is weaker, and strontium is weakest still. All right, so that is decreasing effective nuclear charge. Again, going from the top right to the bottom left for this trend. Okay, let's try another one. Let's put silver, tungsten, and sulfur in order of decreasing effective nuclear charge. Again, going from top right to bottom left. So let's find them on the periodic table. So there's silver, there's tungsten, and there is sulfur. Well, this is pretty straightforward. All right, good. From top right to bottom left, first comes sulfur, then comes silver, then comes tungsten. All right, so sulfur, silver, tungsten. Sulfur has the strongest pull on its outermost electrons. Silver is weaker, and tungsten is weakest still. All right, so there you go. That is decreasing effective nuclear charge. Let's try the last one here. Let's put these elements in order. We'll go red. Of increasing atomic radius. Okay, so increasing atomic radius. So how do we find the trend for increasing atomic radius? Well, once again, elements on the upper right pull very strongly on their outermost electrons, whereas elements on the bottom left pull weakly on their outermost electrons. And what that means is that the elements up here in the top right, those atoms are going to be small. They're going to be small because the nucleus is pulling so strongly on the electrons that it's going to pull them in closer, pull them in tighter, and shrink the size of that atom. And so elements in the upper right are small. Those atoms are very small because they're pulled in close, whereas atoms in the bottom left are bigger. All right. Why? Because they have a weak pull on their electrons spread out. So if we're increasing atomic radius going from small to big, well, the small ones are in the upper left, the big ones are in the upper right, lower left. So this is the trend that we are following, like that. Again, you don't have to draw on your periodic table. I just recommend that for each of these problems, you draw your own little periodic table to map it. And then you'd be like, oh, increasing atomic radius. Well, it's small up here and it's big down there. So we are going in that direction. So you're putting these elements in order from top right to bottom left. Let's do that now. Here we go. So let's find them. Lead, radon. Is that radon or radium? That's radon. I'm right. Cesium and osmium. So let's go. So let's find them up here. Here we go. We have got lead. We have got radon. We have got osmium. And we have got cesium. Great. Is that the ones? Those the ones. Yeah, great. Okay, so if we're moving from the top right to bottom left, then the smallest elements are going to be radon, followed by lead, then osmium is bigger, and then cesium is biggest. So the order here is radon, lead, osmium, cesium. All right? Radon, lead, osmium, and cesium. All right? Because that's putting them in order going in this general direction. Let's try the next one. Nitrogen, silver, molybdenum. Molybdenum? God, I hate that one. Yeah, molybdenum. And gallium. Here we go. All right, so again, we're still going in the same direction, still the same trend, from the upper right to the bottom left. So let's find these elements. Nitrogen, silver, molybdenum, gallium. So here is nitrogen. Here is silver. Here is gallium. And here is molybdenum. Molybdenum. All right, here we go. So putting them in order, it goes nitrogen, gallium, silver, molybdenum. All right, so here we go. The order is nitrogen, gallium, silver, and then Mo. All right. So nitrogen is the smallest because its electrons are being pulled in very tightly. Gallium spreads out a bit more. Silver spreads out even more. Molybdenum spreads out most of all. So this is increasing atomic radius. Okay, guys. So this is how the trends work. Again, first thing you want to do is identify the overall trend on the periodic table here. Figure out which direction you're going. All right. Use a little sketch to identify the direction that you're going to help you out. And then put the elements in order according to that trend. All right, guys, I hope this helped. I'm going to upload this and share it with you all. All right, have a good day. If I could figure out how to stop this.